All right, for 1.6 day 2, we are doing compound inequalities again. So if we look at number 1, remember when there's ever an and problem, it might say the word and, but it also might look something like this. If you don't physically see the word or, it is an and problem. Okay, so and problem is where it overlaps. When you see ones like this, you take the first two parts, so -5 is less than x minus 9, and then the second two parts, which would be x minus 9 is less than 10. Okay, thinking about the whole overlap aspect, both of these equations use x minus 9. Okay, don't just take the first part and then the second part. And what I mean by that is don't just cut it in half. Because yes, this is a true statement, but that doesn't help me solve for x. So on both of these, we would add 9 to both sides. On the left, we would get 4 is less than x, which then we would need to flip around, x is greater than 4. On the right, when you add 9, you get x is less than 19. So we're going to graph both. We have 4, we have 19. Focusing on x is greater than 4, that would be an open circle and to the right. And x is less than 19 would be an open circle and to the left. Okay, being an and, right, and problem, that means we're looking for the overlap. So where both lines are in between 4 and 19. So our solution in set notation would be x such that x is between 4 to 19. For interval notation, our lowest is 4 and our highest is 19. And they're both going to be parentheses because they are not included. On number 2, you have the word or, so this means that this is where one, the other, or both are when we graph them. So on the left, we're going to subtract 2, and we get 3x is greater than 15. And then divide by 3, which gives me x is greater than 5. In the other equation, we would subtract 5 first, and we get 2x is less than or equal to 2. And then we divide by 2, and we get x is less than or equal to 1. So if we graph this, we have 1 and 5. Focusing on the 1, x is less than or equal to it, so it would be closed circle to the left. And in the green, it says x is greater than 5, so this would be open circle to the right. Because this is an or, we just shade both directions. Because one, the other, or both lines have to be above it. For set notation, you would have x such that x is greater than 5, union, x is less than or equal to 1. And you could do that in either order. Interval notation, all the way to the left, negative infinity. And then we go to 1, and then it stops. And it is a bracket because it is included. Then we have our union for or, go from 5 to infinity. And both of those are not included. If we look at number 3, this would end up being an and problem again. So we take the first two. -6 is less than or equal to -2x minus 4. We're going to add 4 to both sides. So we get -2 is less than or equal to -2x. At that point, we're going to divide by -2. And when you divide by a negative, it becomes not only a positive here, but we flip our inequality. Now we're going to end up flipping our inequality right back because we need our x to come first. Our second equation is -2x minus 4 is less than 10. Remember, we take the whole middle term. We would add 4 again. We get -2x is less than 14. Divide by -2, and yet again, when we divide by a negative, we flip our inequality. So x is greater than -7. At this point, we can graph 1 and -7, If we look at -7, it's greater than it, so open circle to the right. And at 1, it's less than or equal to, so closed circle and to the left. Again, this is an AND problem, so we're looking for the overlap or where both lines are above the number line. So that would be between them. So our set notation, x such that x is between -7 to 1. Interval notation, farthest left is -7, farthest right is 1, and 1 is included, so it's a bracket. Number 5, this is an OR problem. So we are looking for one, the other, or both. On the left, we're going to add 7. So 5x is less than 20. Then divide by 5, and x is less than 4. For the right equation, we're going to subtract 3, and -4x is greater than 8. Then we're going to divide by -4, which flips your inequality, and x is less than -2. When we go to graph this, we have -2 and 4. Looking at -2, it's less than -2, so it would be open to the left. And the other one is also less than 4, so it's going to be open circle to the left. Now, because this is an OR, only one line or two has to be above it. Okay, so that means we would start from the 4 and go all the way left. Right? Because one, the other, or both lines have to be above your number line. So set notation is x such that x is less than 4. An interval notation, farthest left is infinity, farthest right is 4, not included, so it's a parenthesis. For number 5, another OR problem. So again, we're just going to subtract 2 on the left. So we get -3x is less than -9. Divide by -3, and x would be, did I say less than? I meant greater than if I said less than. Now it's less than 3, because we have to flip our inequality. On the other side, you can distribute the 2, but I'm going to divide by it first. So we're left with x minus 2 is less than or equal to 3. And then we would add 2 to both sides. We get x is less than or equal to 5. When we graph this one, we have 3 and 5. 3 is an open circle into the left because it's less than 3. And at the 5, it is a closed circle into the left, so it's less than or equal to 5. Because this is an OR, again, we are taking where at least 1 is above it, so we are going to shade it all the way to the left of 5. For set notation, x such that x is less than or equal to 5. Interval, all the way to the left is -infinity, all the way to the right is 5, and it's included, so we need a bracket. For number 6, I would encourage you to try this one on your own first, and then watch me do it afterwards. On the left, I would divide by -2 first. You can distribute it in if you would like. But I'm going to flip my inequality because I divided by a negative. Then all I have to do is subtract 1, so x is greater than -3. For the right, if you subtract 1, you get 4x is greater than or equal to -4. And if we divide by 4, x is greater than or equal to -1. So we have -3, -1. It's greater than -3, so open to the right. It's greater than or equal to -1, so closed to the right. Now this one is an AND, so this is different. If this was an OR, we would go from -3 all the way to infinity. But this time it's an AND, so we need overlap. So the only spots where it does overlap is from 1 to infinity. That's going to end up being our interval notation. Set notation would then be x such that x is greater than or equal to -1. All right, so we have one word problem to talk about. It says Enrique plans a diet for his dog, and his dog name is River. River consumes between 510 and 540 calories per day. If River eats 1.5, which I'm probably going to use 3 halves as my fraction, servings of dog food each day, how many treats can he have? So we're basing it off of this picture over here, right? So 1.5 servings of dog food. So I can take this 320 and multiply it by 1.5 or 3 halves. And then you're going to add it to 15 times however many treats that he's going to have. Now it needs to be between 510 and 540. So there's the type of inequality that we can put together. Okay, so I'm going to just clean it up before I break it down. 320 times 3 halves ends up giving you 480. Okay, so you can either do 320 divided by 2, then times 3, or 320 times 3 divided by 2. Okay, so I'm going to set up 2 equations. We have this one over here. So it would be 510 is less than or equal to 480 plus 15x. You would subtract 480, and you get 30 is less than or equal to 15x, which means when you divide by 15, x is greater than or equal to 2. Okay, now I wrote it that way because I wanted x to come first, so I flipped my inequality. If you do the second side, you get 480 plus 15x is less than or equal to 540. This time when you subtract 480, you get 15x is less than or equal to, and that gives me 60. So when I divide by 15, x is less than or equal to 4. Oh, I don't know what just happened there. Okay, so it says, how many treats can she have? So she can have between 2 and 4 treats. On 7b, it says, suppose River has new treats that are 410 calories each. Sorry, 410. Wow, I read that really well. Suppose River has treats that are 10 calories each. How many of these new treats can she have and remain in her calorie range? So we're going to essentially take these equations and rewrite them just with the 10. So we'd have 510 is less than or equal to 480 plus 10x. And this one would end up being 480 plus 10x is less than or equal to 540. Just like before, we would subtract 480 over, and we would end up getting 30 is less than or equal to 10x, which would mean we would get 2 and then have to flip it. Let me try that again. We would get 3. On the other one, when we subtract 480, we get 10x is less than or equal to 60. So when we divide by 10 over here, this is now 6. So she can have between 3 to 6 treats.